Hello dear students. So today's lecture is about again differential equations, but today we are going to discuss about what's basically the singular point or what's ordinary point or what's that regular singularity or irregular singularity, right? So there are different names for this, or you can say that regular singularity, or this is called non-essential singularity, or if it's irregular singularity then it is called essential singularity. So before that, in our classwork, we have already discussed about what is basically singular point, right? So let me revise a bit because this is the YouTube this video. So first of all, at least you should know about what's basically that singular point and what's ordinary point, or you should know what's basically that regular or irregular singular point, right? So first, as I wrote here, that is basically singular point. So if you have some differential equation, homogeneous differential equation like px y double dash of x plus q of x y dash of x plus some r of x y equal to 0, right? So if we consider some point, अगर हम कोई point लेंगे x equal to x naught, so at x equal to x naught we can say that this x naught will be the singular point if p of x will be 0, right? So that means if p of x will be 0, so in that case this point x naught is called the singular point, right? If p of x is not equal to 0 at x equal to x naught, then x naught is called the ordinary point, right? So this was how you can distinguish between a singular point and an ordinary point. So second case is that is if you talk about that what is basically regular that singular point, or which is called the non-essential singularity, and second is if you talk about that irregular singularities or irregular singular point, right? It is singular point, but we can have regular as well as irregular singular points, or we can have essential non-essential singularity which is called a regular singular point, or we can have essential singularity which is called an irregular singular point, right? So for that case, in order to check that a given differential equation has a regular singular point or an irregular singular point, so if it satisfies some limits, because I cannot discuss that in detail, but so with the help of these limits, if those limits will be finite, so that means if we choose that, because this differential equation can be written as y double dash plus that qx upon yx px y double dash plus y equal to 0, right? Or you can say that y double dash plus that d dash of x y dash plus some q dash of x of y. So that means our this p dash of x will be equal to, that's equal to qx upon px, and that q dash of x will be equal to और x upon, right? तो अब अगर हमारा जो लिमिट होगा, if we take that limit, because we are saying that x naught, we need to check whether this x naught is a regular singular point or it can be a regular singular point. So for that case we need to check two limits. So if these limits will be finite, so when they have a finite value, so then we can say that that point will be, that is called a regular singular point, right? So the two limits that we need to check that, so first is that limit x tends to x naught, so if it is finite, and limit that means less than infinity or less than infinity, right? So when these limits converge, or you can say that these are less than infinity, we can say that x0 is called a regular singular point. So in that case we can say that the singular point is, that's called a regular singular point. Okay, and otherwise it will be irregular. So that means otherwise you can write So there is another name for this regular singular point, that's called a non-essential singularity, and an irregular singular point, it is called essential singularity, right? So that means if we have some differential equation, we can check whether first of all we need to check whether that point, whether the coefficient of that second double derivative is if you put that equal to some zero, so whether this will vanish or not. So we need to check that. So that means we need to check whether that has ordinary or the singular point, right? Let us take one differential equation. Suppose we have already solved some problems in our classwork. So today I am taking one more problem, that is basically we need to show that the Laguerre equation, we have some kind of differential equation, it's called a Laguerre equation. As we have already talked about that Gaussian differential equation, we checked that at x equal to 0, so whether that x equal to 0 is that, first we need to check whether it is, if it is ordinary point, no need to check, because if it is ordinary, so there is no problem. But if we have some singular point, so we need to check what kind of singular point it is, right? So we need to check these limits, right? That limit x tends to x naught, that x minus x naught p of x, and those two limits, right? So now we have our differential equation, so that is basically a Laguerre equation. So we need to show that it has regular singularity. So it has regular singularity at x equal to 0, and it has irregular singularity at x equal to infinity. तो हमें ये प्रूव करना है कि अगर हम x 0 लेंगे तो वहाँ पे इसका रेगुलर सिंगुलर पॉइंट होगा. So that means those two limits should converge, right? When they will converge, it has regular singular point. And second, at x equal to infinity, we need to prove that it has irregular singular point, or which is called essential singularity. So that means at x equal to infinity, both the limits they diverge, right? So we need to check those limits first, right? So before that, because if you have a look on this differential equation, so our differential equation is that is x y double dash plus 1 plus x minus y dash plus ay, that's equal to 0. Okay. So first of all, we need to check whether that p of x, if you put x equal to 0, that p of x will be 0. This one coefficient, right? So that means this x equal to 0 is singular point for this. So that means this x equal to 0 is the singular point for this differential equation. Okay. So now we need to first look for what is the value for this p dash of x and q dash of x, right? So for that case, I can rewrite this equation as y double dash plus equal to 0, right? Because I simply that divide by x here, so this is y double dash plus 1 minus x, because we need to check what should be our p dash of x and q dash of x. So just have a look on this one, because we need to check what's our p dash of x, right? And we know that, so we need to check these two limits. So that means limit x tends to x naught, that's p dash of x. So it should be finite, because we need to check that x equal to 0 is, that's regular singular point, right? So we need to check these two limits. So if they will converge, so that means it has regular singular point, because we need to show that for this differential equation, right? So that means we can rewrite this differential equation in this form, right? So if you compare this equation, तो अगर इस equation को मैं compare करूँगा किससे? That is y double dash plus that p of x of y तो अगर इस differential equation को मैं इससे compare करूँगा, because we need to check p dash of x क्या होगा and what is q dash of x. So that means our p dash of x is 1 minus x by x and our q dash of x is 1 by x. Now we have already checked that it has this singular point at x equal to 0. So that means our x naught equal to 0, because our limit goes from x tends to x naught. So जो हमारा x naught है that is 0, because 0 is basically the singular point for this differential equation. Okay. So we can write then p dash of x a by x. So a is some constant value. It has some constant value. Now you need to check those limits. So that means we need to check that limit because this x will cancel here, so this will be equal to plus, so which is less than infinity. That means it has a finite value. Okay, so the value, because it is plus 1, when you put that x equal to 0. Okay, now second limit is that limit and what is q dash of x? So let's say by x. Right? Because so this x can, so one x will cancel with this, and we can have only that's x into a. But x tends to 0, so we have, so its value will be 0. So which is less than infinity, or this will be finite. Okay, because it's clear. So that means both the limits are finite. So when both the limits are finite, so we can say that x equal to 0 is regular singular point. So we can say that as both limits are so that means x equal to 0 is regular singular point, right? Now second is, so as per our this question, so question says that, so we need to check that, we need to show that this differential equation has a regular singular point at x equal to 0. So this was the first case, हमने prove किया. So second इसका है, we need to check it has irregular singular point at x equal to infinity, right? So that means where we can rewrite this as, so at x equal to infinity. So how we can do, because we have already, because it will take one more lecture, so we are basically calculating that p, that x inverse, right? Because we do some transformation here, because if you put that x equal to 1 by z, right? So then as x tends to infinity, z tends to 0. So we do this transformation, so we can put that x equal to 1 by z. And we have already calculated that in our classwork, that so what should be our p dash of x, what's our q dash of x in that case, right? So when we do this kind of transformation, so we can rewrite that what's our p dash of x, p dash of z now, because so these are basically, we have already, I already take one lecture on, full lecture on this. So how to transform this in terms of that z, because we are doing this kind of transformation. We are saying that x should be equal to 1 of z. So we need to substitute in our that original differential equation, and from there we are calculating what's our p dash of z and q dash of z. So after that we are basically getting that p dash of z equal to 2z p z inverse. Z inverse means because we have x inverse, or you can write this as, right, because you can rewrite this way, huh? So that means, okay. So you can write down now p dash of z is basically, we know that what's our p of x. So p dash of x is already, that's 1 minus x upon x. So ये already हमारे पास है. So how we can transform it to z, because we need to calculate p z inverse. So that means take the reciprocal, because x equal to 1 by z. So this will be p dash of z inverse equal to 1 by x. Because x is divided to both the terms, we can write 1 by x minus 1. Or this will be equal to that z minus So this is our P dash of Z inverse. And similarly, we need to calculate what's Q dash of Z inverse. So first let us check first limit. So first limit is, okay, let's write Q Z inverse. Q Z inverse. Alright. So as you know that our Q dash of Z is equal to Q dash of X is equal to, that's A by X, and this will be Q dash of Z inverse, that's equal to A into Z, because X is equal to 1 by Z. So X किसके बराबर है? That's equal to 1 by Z, so you can write AZ. Huh? So that means this Q dash Z inverse will be equal to, right? So that means हमारे पास ये भी है. We have this P dash of Z. So P dash of Z inverse is this one. So we can calculate what's P dash of Z. So what's our P dash of Z here? P dash of Z. So that's equal to 2Z minus EZ inverse upon Z. And we have already calculated what's our P dash of Z inverse. So that's equal to, okay, what was that? Okay, so that's this. So that's Z minus 1. Okay, so that means this will be equal to Z minus 1 upon, that's equal to, because this will be 2Z minus Z plus 1. That is Z plus 1 divided by Z. So that means we have calculated what's our P dash of Z. Similarly, our Q dash of Z will be equal to, so that will be Q of Z inverse upon Z raised to 4. So that's equal to, right? So that means हमारे पास अब P dash Z भी है. So that's Z plus 1 by Z square, and our Q dash of Z is equal to A by Z cube. Now we can check those limits. So now the limits are, so earlier limit was limit x tends to x naught, x minus x naught, that P dash of x. अब ये हम यहाँ पे आएगा Z tends to 0, because we are transforming that x into Z. We are saying that x should be equal to 1 by Z. So that means we need to check those limits. That limit Z tends to 0, Z minus Z naught, P dash of that Z. So that's equal to, so that is Z minus 0. Okay, so that's equal to, because one Z will cancel with this thing. So we can have, when Z tends to 0, so this will be infinite. Right? So one limit will be infinite. Because one Z will cancel with this, still we have one Z in the denominator. So because we are saying that Z tends to 0, because x is equal to 1 by Z. तो हमें देखना था, we need to check that the singularity at x is equal to infinity. So because we are saying that अगर x 1 by Z के बराबर होगा, so as x tends to infinity, so Z will tend to 0. So this is clear. So that's why I put the limit Z tends to 0, Z minus 0. This. So one Z will cancel with this thing. Simply we have one Z in the denominator, and when you put that Z tends to 0, so this will be infinite. So that means it gets diverted, right? And similarly, you check the second limit, that is limit Z tends to 0. Okay, so that will be equal to, A Z cube. So you just check that what's our that Q dash of Z. So that's A by Z cube. So that's A by Z cube. So that's equal to limit okay, this will be equal to, this will be infinite, right? So that means यहाँ पे जो second case है, जब हमने x and we put that x tends to infinity, so both the limit is diverged, right? So that means we can say that we can say, therefore we can say that x equal to infinity or z equal to 0 is irregular singular point or essential. तो इसको मैं irregular singular point कहूँगा, or we can say that it's called essential singularity, right? Because we cannot remove that. So because that's what we need in our topic. Because if you remember that, so our equation we need to check that it has that regular singular point at x equal to 0. So we have checked that, and similarly it has that irregular singular point or that essential singularity at at x equal to infinity or z equal to 0, right? So there are so many problems if you have if you have a look on the equation. So first you need to check that whether it has singular point or not, or if it is ordinary point, no need to check these limits because there is no fun of doing this thing, right? So first priority goes to that, means you need to check that whether the coefficient that which is multiplied to first second derivative, whether it is 0 or not. If it is equal to 0, so it has singularity at that point. So then we can check what kind of singularity it has. Either it has essential singularity or non-essential singularity. So similarly, you can have so many equations, differential equations in mathematics. You can check what kind of singularity it has. So provided it has some singularity at some x equal to x, right? So this was so far so we can discuss some more problems maybe on this or some new topics that we are going to discuss in our that classwork. So hopefully you will get to know what kind of problems we are going to discuss in our coming lecture, right? Thank you.